The purpose of this video is to teach you how to interpret infrared spectra. Now, infrared spectra is a really powerful analytical tool to tell us the types of bonds present in a sample of a molecule. At A level, the key bonds that we are going to be looking for are OH bonds, either in alcohols or carboxylic acids, because they behave slightly differently, or the CO double bond, the carbonyl bond, present in aldehydes, ketones, carboxylic acids, and esters. And basically, infrared tells us whether these bonds are present in the sample or whether they are not. Okay, some background information about infrared spectra. How does it work? Well, different bonds, OH bonds or CO double bonds, will absorb infrared of different wavelengths. So here we've got an example. Let's imagine I've got a sample of a molecule, and this molecule contains the carbonyl, the CO double bond. At longer wavelengths, the carbonyl, the CO double bond, doesn't absorb the infrared. So if we try to pass some infrared light through our sample at the longest wavelengths, that light is not absorbed. It passes through the sample and it gets to the detector. At really, really short, down here, really short wavelengths, again, the carbonyl bond, the CO double bond, does not interact with that infrared light. It doesn't absorb it, so the light gets through to the detector. But at a very specific wavelength, you try and pass that light through the carbonyl double bond, it doesn't get through. The bond absorbs the light. It stops it getting through to the detector. So infrared is working by particular bonds absorbing light at particular wavelengths. Now, typically at A level, what we're trying to do is teach you how to identify a sample by looking at a spectra to identify particular absorbances. And you get a data table like this in the exam. And what we've got to be able to do is describe what the absorbances look like. What do they look like and where are they? And then use those to talk about the types of bonds which are present in the molecule. Let's work through some examples. Okay, here's a really, really rough outline of what an infrared of an alkane would look like. Now, alkanes contain two types of bonds: carbon-carbon single bonds and carbon-hydrogen single bonds. Now, if I look at my data table, I can see that for a carbon-hydrogen bond, you would expect to get an absorbance somewhere in the region of 2850 to 3100. The scale, it's a bit crazy, this scale. It's the wave number scale. Why do we use this? I've no idea. The wave number is the inverse of the wavelength. I think it's just an easier number to use. So up here, we've got an absorbance. The light hasn't been able to pass through the sample because these bonds have absorbed the light at this wavelength around this area. And we can see that that corresponds to the carbon-hydrogen bonds. Now, let's face it, that's not really going to tell us very much about an organic molecule, because organic molecules contain carbon-hydrogen bonds. And if you find out that you've got an organic molecule with carbon-hydrogen bonds in it, you've not really learnt very much. Down in this region, this is called the fingerprint region. And as a human being, it's not really very much use to me. I can't really do very much with this fingerprint region. I'm not able to interpret that area. It's too complicated. Now, if I was a computer in a spectral database, I would be able to analyse that. But I'm not. So neither are you. You're not going to be expected to analyse this area on an A-level exam. We're interested more in what's going on in this region. Now, this is roughly what the spectrum of ethanol would look like. I can see the fingerprint region down here, which I'm going to ignore. I'm not interested in. Here, I've got my carbon-hydrogen bond absorbance. Here, above 3000, there's another, more interesting bond present. So this absorbance is indicative of a particular bond present in my molecule. Now, hopefully, you're clearly aware that an alcohol like ethanol contains an OH bond. And you would expect OHs to absorb in this region of the spectrum. And it doesn't matter whether I'm talking about ethanol, propan-1-ol, a carboxylic acid, anything with an OH bond, you're going to see a broad, that means wide, absorbance in this region. Now, because I'm talking about an alcohol, the position of the OH absorbance in an alcohol will be slightly different to the OH absorbance in a carboxylic acid. And you can use your data sheet to see what those differences are. So in carboxylic acids, we'd expect to get a broad absorbance in the region of 2,500 to 3,300. Whereas in an alcohol, this absorbance will be further in this direction, in the region of 3,200 to 3,600. And that's probably as about specific as you could get. They're both going to look relatively broad. So that's a real key. The moment you see something in this region that's broad or wide, you need to be thinking, this molecule contains OH bonds. In our second example, well, guess what? There's a broad absorbance in the region somewhere between 2,500 and 3,500. Now, I imagine that that is going to be an OH bond, but because it's broad and it starts at a lower value, 2,500, I'm already thinking about carboxylic acids, the OH bond in a carboxylic acid. Now, if I think about ethanoic acid, this is a sketch spectrum of ethanoic acid, I can also see that besides my OH bond, I've got the CO double bond. Looking in this region, round about this value, somewhere around about 1700, in the region between 1630 and 1820, you're going to get a very narrow, sharp and deep peak or absorbance. That's indicative, or that indicates the CO. So I've got this bond present, and I've got this bond present. And that's all that infrared would be able to tell us. It wouldn't be able to tell me the number of carbons or the number of hydrogens or anything like that. All it can do is tell me which bonds are present, and conversely, which ones are not present. The moment that I see these two absorbances, and particularly with the fact that this OH absorbance is in the region for a carboxylic acid, I know I've got a carboxylic acid. I don't know necessarily which one, but I know I've got a carboxylic acid. So infrared is basically telling us what type of compound we have. Is it an alcohol? Is it an aldehyde or ketone? Is it a carboxylic acid? Okay. Here's a third example. What I'd like you to do, I'm going to pause the video in a moment. I'd like you to identify which bonds are present, which bonds are not present. Now, looking at this this particular spectrum, I can see, first of all, there's no OH bonds in this molecule. I don't have that kind of broad absorbance. This little thing up here is going to be caused, because it's in this region, by carbon-hydrogen bonds. And that's telling me nothing. So there is no OH. In this region, somewhere in the region of 1630 to 1820 or thereabouts, I've got a carbonyl bond, a CO double bond. So what type of compound might I have? Well, I know, and hopefully you know too, we could be talking about aldehydes. We could be talking about ketones. We could be talking about a group of compounds called esters. That's something that we look at when we're in year 13. But what I cannot have is a carboxylic acid. Because for a carboxylic acid, the OH bond in the correct region would need to be present. So I could have one of these three compounds. Which one? No idea. Infrared's not going to tell us that information. So to summarise, infrared tells us which bonds are present in our sample. To answer an exam question, what you need to do is identify particular bonds because of their absorbances. And what you would say is there is an absorbance in the region. You'd go to the data sheet. This is clearly a CO double bond. You'd go to the data sheet that you're given in the exam. You'd find the C double bond O on the infrared data sheet, and you'd use the range that the exam board give you. You wouldn't start trying to make your own numbers up. Play it safe. So I would look at the data sheet, and I would be able to say, okay, in the range 1630 to 1820, I've got a CO double bond. There is no OH bond present. Say what there is, and if necessary, say what there isn't.